Okay. Intro to statistics. We talked about the statistics or the statistical problem-solving process last class when we introduced our first kind of activity and we did everything. We asked a question of interest. I asked, do you remember things better if you see things or if you hear them? Then we produced data. You guys were the individuals that did the test, and you wrote down how many number pairs of numbers on that card that you saw and remembered, and then you did the same thing with hearing. Your partner read it aloud 3 times. We then gathered the data, we analyzed the data. I want to put A here, but I feel like it's a different letter. Ask a question, produce some data, analyze the data, and then we made a conclusion. What was our conclusion? That on average, you remember things better when you do what? See it or hear it? See it. There you go. We did the entire process with our activity. Now we're going to focus on each part of the process throughout the course. The first 3 chapters are these 2. That's a horrible job. This is what we're going to focus on over the first 2 tests. Question 1 and 2. I don't like these first 2 tests because it's all words, it's all concepts, it's all definitions. I can't wait till we get to chapter 4 when we start actually using numbers. We start analyzing data, producing graphs, describing data, okay? But we have to deal with this part 1 and part 2 of this process, or else we're not going to have a general understanding of statistics, okay? Now, first terms we need to know, individuals and variables. Individuals, here's the proper definition. I'm going to give you a different definition. Individuals are the objects described by a set of data. People, animals, or things. Individuals are where the data comes from. Individuals, where data comes from. It does not have to be people. It does not have to be an animal. It does not have to be a thing. It could be more of like a concept. We could be getting data from plays in a football game. We could be getting data from basketball games and just like the amount of shots taken in a basketball game, okay? Doesn't have to be a person. Can be something else, okay? It's just where data comes from. A variable is the data that's being gathered. It says it's any characteristic of an individual. Variables can take different values for different individuals. I like just to say the variables are the data. The data being gathered. And there's 2 types of data, categorical and quantitative. Category are things that can't be quantified, like job type, like gender, like race, like hair color. It's just you fit in a category. Quantitative are things that typically take numerical values. Sometimes they don't have to take numerical values, but the key to quantitative variables is that averaging makes sense. Category, I would just write job type, gender, race. Quantitative, just be numbers, and averaging makes sense. We're going to go through some examples, and you're going to describe the individuals, the variables, whether they are categorical or quantitative. First is example of a few lines from a teacher's gradebook. First question is, what individuals does this data describe? So we have the name of some people, we have the gender, the grade level, the calculator number, and the test grade. What do we think, Mr. Holtz? What are the individuals in this case? Yeah, this is easy. The individuals are what we know individuals to be, people. Individuals in this case are the students. Now, next question, what are the variables? And so what are the variables? We figured out where the data came from. The data is coming from individuals. Now the variables are what is the data that we are gathering. So figure out that, and then are they categorical or quantitative? I want you to talk about these answers with your neighbors. Make sure you have the same answers as they do. Ready, set, go. Talk with your neighbor behind you, to the right of you, to the left of you.
Gender would be categorical. Like the grade. Yeah, that would be quantitative.
Quantitative, yep. All right. Mr. Fife, pick a number between 1 and 31. 5. Pick another number.
10.
Pick another number.
16.
Okay. Ms. Loeffler, what did you come up with? What variables does the data describe? Exactly. All the rest of the those columns are the variables. And which of them are categorical and which of them are quantitative? Yep. Right. So I would say yes on the gender. Yes, the grade level is quantitative. It's numerical. We can find the average. And yes on the test number. But the calculator number is one of those things where if I did find the average of the calculator number, would it help me make a conclusion? I don't think so. It's more of just like, this is the calculator that you have. If I took the average of those three numbers, it's like, oh, they have the average of calculator number, blah, blah, blah. This doesn't really make any sense. Also, I think that they say that grade level is categorical. No, just gender and calculator number, which is what I like. And then quantitative, grade level and test grade. I can find the average grade level. So most of the students are in 12th grade or like 11.8th grade, which is fine. It just says you're closer to 12th. And then the test grade. Good. Next one. This is an example of a biologist logbook. We have, I don't know why this background is green. It doesn't really work. We'll fix that in the future. We have a duck tag number. So it looks like a biologist went out into the field, captured some ducks that were tagged, then measured their height and their weight. Same question, what is the individuals? And the individuals in this situation are the ducks. They are what we are gathering our data from. Then what are the variables, and are they categorical or quantitative? Go talk amongst your friends. Okay, who likes biology? All right, Miss Nebergitch. What variables does the data describe? And are they categorical, quantitative, mixture? Yeah, they are both quantitative. You could take the average of both. That's good. Next example. An example of an offensive football coach's game log. We have a play number, whether we are run or pass, the yards gained on the play, and then the offensive football coach rated the execution level of the play, whether it was good, poor, excellent, or maybe something else. Okay. First question, What are the individuals? Talk amongst your neighbors. What are the individuals in this situation? All right, Ms. Offenbecker, what do we think? The play number is correct. It wouldn't be the players in the football game. Okay, yes, the players are, executing the play. It would be the actual play and the result of the play. So in this situation, the individual is not a person. It's more of like an idea, a thing. So that is where we're getting our data from. All right, now what are the variables, and are they categorical or quantitative? Go. All right, who plays football or likes football? All right, Mr. Medina, what are the variables?
The variables are run, pass,
Yes, those are the variables. Those are the data we are gathering, whether it's a run or pass, the yards gained, the execution level. Which of those are categorical, where averaging doesn't make sense? Okay, and then the yards gained would be quantitative. Does anybody have a different opinion about which ones could be different? Maybe execution level could be quantitative. How would we figure out the average execution level? That's exactly right. No, it's good. So you could say, all right, maybe good is 2, poor is 1, excellent is 3, and all of a sudden you could see the average execution level. Could you do that for run and pass? No, but you kind of could find the average, or not necessarily the average, but the percentage of your plays that are pass and your percentage of your plays are run. That's still something that is important, but I would say that that's probably categorical, and you could just kind of quantitate that data if you wanted to. Okay, and definitely yards gained, we can find the average. Good. Next terms we need to know, the difference between a population and a sample. And then what we do when we produce like a number from a population, so an average, or we produce a number from a sample. So you don't have to write all this down. Let's just look up at the board for now. I say the population of interest in a statistical study is the entire group. Okay, a population is the entire group. You don't have to think of a population as necessarily people. It's just the entire group of whatever the variables are, or the individuals, sorry, whatever the individuals are. Population, entire group of individuals. So in the previous example of the football plays, we had plays. The population would be all plays that we can record, every single play. That's a population. Next, and I'll come back to what a parameter is a sample. A sample is a part of the population. So in the previous example, plays 5, 6, 7, and 8 was a sample from the population of all plays. Got it? Population is just all of the individuals being anything that we are gathering the data from. Okay, now we have a parameter and a statistic. These are both numbers. This is a number that we get from data from a population. So if I polled all of the plays, so I have the population of all of the plays, and I found that our average yards gained per play was 6 yards, that would be a parameter. It is a number that you get from a population. A statistic is a number gathered from a sample. So, in the previous example, those 4 plays that I had, if I found the average yards per play for just those 4 plays, that average number would be the statistic. And we can compare the statistic to the parameter. Sometimes statistics will help estimate a parameter. If we want to know what the average weight of every student is in Lake Travis High School, I could conceivably find out the weight of every single student, okay? But it might take me some time to get the data from that population. But instead, I could take a sample from maybe a couple of classes, find that average weight, and then that will help estimate what I think the parameter is. Parameter deals with populations, statistics with samples, okay? That's an easy thing to remember. The P goes with the P, the S goes with the S. Statistics and samples. I don't like this example. I'm going to skip it. Okay. Are we talking about populations or samples, or what do we have? So let's go back to those 3 examples. The first example is I'm a teacher of a class, and I wanted to find the average test grade of that class. What would be the population that I am surveying, that I could survey? And would I use a sample or a population to see how students did? Talks amongst your friends about that. So if I call on you, you'll know how to answer. I'm just talking of a class. Let's say this class. Okay. Mr. Kucharowski, what is the population? Everybody in the room. Correct. If we're talking about wanting to find the average test grade of a class, it would be everybody in the class. This is the population. If I wanted to find the average test grade of this class, I would use all of you, right? That's the population I'm talking about. Would I use a sample or a population to see how students did? Population, easy for me to do. There's only 31 of you. I can find your test grades. I can average them together. Perfect. Let's say I'm a college professor and I have 20 classes or something like that. Okay, and I'm teaching the same thing. The population would be all of the students in all of those classes. Okay, I could conceivably get the test grades from all of the students in all those classes. But maybe what I want to do is see how they're doing from the first 2 or 3 classes, and then maybe I will have a different review session from the other classes. What I could do is just find the average test grade of 3 classes. That would be a sample where I'd produce a statistic, and that could estimate what my population is going to do. Maybe I'd adjust things from there. Okay, so samples are just part of the entire population. 3 classes out of the 20. Find the average test grade of those 3 classes. That's a statistic that I'm producing, which potentially could help me determine what the parameter is going to be, which is the overall test grade of all 20 classes. Okay. Next question. The biologist tracking ducks, their height and the weight in a state forest. What would be the population? Would you attempt to survey the population for the average height or weight, or do something else? Talk amongst yourselves about that situation. All right, Miss Weldon, do you like biology? I never liked biology. All right, cool. What is your population in this situation? Where? All the ducks in the country? No. It's just all the ducks in that state forest. If I'm just tracking ducks in the state forest, it would be all of the ducks in that state forest, not all of the ducks in the country. Would I attempt to survey the population for average height and weight of those ducks? Just do a sample. I would produce a statistic, which would help me estimate a parameter. Okay, I'm an offensive football coach wanting to see your average yards per play. What would be the population, and would you use a population or a sample to see how your team did? Mr. Fife, you're just going to answer this, right? You play football. You got the shirt on. Okay. It's a pretty sweet poster, right? You got Clyde Drexler in here, Dominique Wilkins. It's old school. Okay. Anyways, let's read the question again. You're an offensive football coach wanting to see your average yards per play. That should be a period. What is the population?
Yards?
No, that would be the variable. That's the data that I'm gathering. All of my plays, exactly. All of my plays would be the population. Would I use a population? So would I use all the plays to find my average yards per play, or would I use a sample? So just, yeah, I would use all of them. If I have all of them, they're easy to find, and I can take the average of all of my plays. Boom, I'm going to use all of my plays. So that's populations versus samples. Next one, let's talk about parameters versus statistics. So remember, parameters and statistics are numbers. So the teacher finds the average test grade was an 83% of all of her students. That was the teacher who averaged the test grade. Ms. Foco, is that 83% a parameter or a statistic? So statistic comes from samples. Parameters come from populations. That 83%, since it's all of her students, that's got to be a parameter. Next one, we got two numbers. One's probably a statistics, one's probably a parameter. The biologist is checking her sample of ducks to see if ducks are maintaining an average weight of 5 pounds. Her sample gives her an average of 4.6 pounds. Who haven't I called on? Miss Rios. Have I called on you yet? Yeah. Here we go. Miss Rios. One of them's a statistic, one of them's a parameter. And the parameter would be the 4.6. Remember.
Wait, no. Sorry.
Okay. Samples give you statistics. From the sample of those ducks that she had tagged, that's my statistics. My parameter, that comes from an overall, and that necessarily might not necessarily be a parameter because we can't really get the population, but it's something we could be using. And then finally, the offensive football coach finds out that overall his team averages 6 yards per play. However, he notes that at the first drive of the second half, his team comes out slow and only averages 3 yards per play. All right, Mr. Roberts, which one is the parameter and which one is the statistic?
The statistic is 3 yards per play, the parameter is.
Perfect. Okay, do we understand the differences? Excellent. What else do we got? We also have to talk about 2 types of studies that we will be looking at, observational studies and experimental studies. We're going to time this perfectly. Observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. Observational studies are people in trees looking at things. Okay? They are removed from the situation. They are not influencing the situation whatsoever. Zero influence. Think people in trees. Looking with binoculars. So the purpose of an observational study is to describe some group or situation. Yeah, sure. Well, that's the purpose of any study. Don't worry about that. Okay? But observational is just looking, not influencing. Experiments. Experiments deliberately impose treatments. This is the key word. Experiments use treatments. They influence things. They want to influence things because they want to see something different. They want to see an improvement in something. Purpose of an experiment is to study whether the treatment causes a change in the response. This is the whole placebos come in with experiments where you need your comparison. You don't necessarily have to have a placebo though. Don't care about that or that. Okay, observational studies or experiments. A high school teacher wants to determine the relationship between students using their phone when they shouldn't be and their overall grade in class. Great study, might be me, who knows. The teacher notes at the end of the period which students had their phone out during the class period and keeps tally of those students over the course of the year and compares the data to final grade. Would that be an observational study or an experiment? Observational, exactly. I'm not influencing. I'm letting you do whatever you want to do. I'm just going to take note of it. You want to determine what the most popular cars are on campus. To do this, you go to the parking lot and record different types of cars for several samples from different areas of the lot. Would that be observational, where you're not influencing things, or experiment when you are? Observational. Finally, an insurance company wants to research if wearing a Fitbit improves the overall health of a person. They take a group of 200 people and record baseline health measurements. Then they give them a Fitbit, and after a month record the same measurements again. That would be a what? Okay, I have a question. One more example. I want to figure out the average time it takes to walk from this classroom to the cafeteria in the annex. Okay? All right. What I'm going to do is I'm going to take some students and I'm going to tell you, okay, so Ms. Pushman, me and you, right after class, I'm going to get a stopwatch and I'm going to time you. I'm going to walk right next to you and time you, okay, to see how long it takes you to get from here all the way over to the cafeteria. Okay? Ms. Pushman, are we having an observational study or an experiment? That's actually correct. Why? You'd think, oh, aren't you just watching the person? Right? Wouldn't you think I'm watching the person walk from here to there? Why isn't that an observation? Mr. Riley? Exactly. It's the influence. I'm walking next to her. I have a stopwatch on. She's probably not walking on her normal pace. Okay? What would make that same idea an observation? Yeah, maybe if I know she's going to the cafeteria, I literally just like wait for her to leave, or I start a watch, call somebody in the cafeteria and tell them like, hey, when she shows up, let me know. And then all of a sudden, zero influence involved. Okay? So that's how you got to think of it. Observation and no influence whatsoever. Experiments, there is some. Good. Where are we? Okay. This is APAC. I was correct. We already talked about. That's what we're focusing on. These first two things are what we focused on for the first 3 chapters, which will consist of 2 tests. Once we are done with those tests, this class will get harder for some of you, easier for others. I'm going to end there. All right. Do you have your books? Great. Your homework is out of your book. Look at this. Good at this game. Okay. I will put up the homework assignment. If you don't have a book, share with somebody else. You are to work during CAV time. You